What if the chair you ordered could just assemble itself? Or what if your cracked phone screen could heal on its own? This isn't science fiction. This is the future that's being built right now in materials science labs all over the world. And today, we're going to take a look at the work of one researcher who's making it all happen.
So think about it for a second. You've got smart materials that can change their own shape. You've got the 3D printers that can create them, and then you have the whole question of how we recycle them. They might seem like totally separate fields, right? But they're actually all key pieces of the exact same puzzle, building a smarter, more sustainable, and way more dynamic future. And that puzzle really starts with this modern-day quest for better materials. Because when you stop and think about it, from the Stone Age to the Silicon Age, human progress has always been defined by the stuff we can build with.
I mean, just look around you right now. Your phone, your desk, the very building you're in, it's all made of materials. For pretty much all of history, we've been limited by what we could find in nature. But the really big question that researchers are asking now is, what if we could design materials from the atom up? What if we could create things that are smarter, stronger, and way more sustainable than anything that's ever come before?
And that's not just some hypothetical question. It is the mission that's driving scientists all over the world. To really understand how this all works, we're going to zero in on the research of one specific innovator.
Okay, I know this might sound a little academic, but it's actually a really powerful mission statement. What this means is creating the fundamental rule book for the materials of tomorrow. See, if you can perfectly understand and predict how a material is going to respond to stress, or heat, or electricity, then you can build it to do exactly what you want.
And the person behind this particular mission is Dr. Mohammad Heidari-Rarani. He's an associate professor at the University of Isfahan, and his lab is right there on the front lines of this materials revolution. So how does a mission like that actually translate into practice? Well, let's step inside his composite lab, so to speak, and see the specific challenges that he and his team are tackling. Okay, so the lab's work covers pretty much the entire life cycle of a material, from designing and making composites to testing exactly how they break, and even figuring out how to recycle them. But two areas on this list just jump right off the page. They sound like they're straight out of science fiction. So let's take a closer look at those: 4D printing and metamaterials.
First up is 4D printing. So if 3D printing is all about creating an object in space, 4D printing adds that fourth dimension, time. This means a 4D printed object isn't static. It can actually change its shape or its function all on its own when it's triggered by something like heat or water or light. Imagine that flat packed chair that just assembles itself as soon as you take it out of the box. That is the kind of potential we are talking about here.
And next, we've got metamaterials. This is another really mind-bending concept. These are not materials you just dig out of the ground. No, they're artificially designed, and their amazing properties come from their structure, not just what they're made of. Think of it like building with special Legos. The way you snap them together is what gives the final creation a superpower, like being able to bend light or sound in ways that are totally impossible for natural materials.
So why all this focus on composites? Well, a material like steel is strong, sure, but it's also heavy, and its strength is pretty much the same in every direction. Composites are a total game changer. By layering different materials together, you can make them incredibly lightweight, yet even stronger than steel, but only in these specific directions where the stress is going to be. And that means less weight, less wasted material, and just vastly better performance.
Which brings us to the most important question of all. So what? What's the point? This research isn't just for academic papers. It has real, tangible, world-changing impact. Let's connect the dots and see how these ideas build the future that we're all a part of. When you see a research area called fatigue and fracture, what does that really mean for you? Well, it means understanding precisely how and when a material is going to fail. And that knowledge, that understanding, leads directly to building safer cars, safer planes, and safer bridges, the structures that we literally bet our lives on every single day.
And what about recycling of polymers and composites? This is a huge one. A lot of these amazing new materials are really hard to recycle. So figuring out how to do that effectively helps us tackle one of the biggest environmental challenges on the entire planet, creating a world with way less plastic and material waste.
And finally, additive manufacturing, which you probably know better as 3D printing, is completely revolutionizing how we make things. It's shifting us away from these massive, one-size-fits-all factories and toward a future of on-demand, highly customized manufacturing. We're talking about everything from a medical implant that fits you perfectly to a rare replacement part for a machine.
The Stone Age was defined by stone.
the Iron Age by iron. So what material will define our future? It probably won't be just one single thing. It's going to be a whole new generation of smart, designed, sustainable materials, born in labs just like Dr. Heidari-Rarani's. So the real question isn't just what we will build with them, but what should we build?